Okay, so in this section we're going to discuss about rational function, and first of all we find the domain and then different things like asymptotes and plot the graph, and ultimately we use rational function to solve some application problem. So if your function is in this form where p of x is a polynomial and q of x is another polynomial, it's like a fraction, that is called a rational function. A rational function is a function that is a quotient of two polynomials. But keep in mind, the polynomials on the bottom part, it is supposed to be non-zero, because if it's zero, then the function is undefined. So it's like a rational number, but in terms of function, polynomial over polynomial. Whenever we try to plot the graph of rational function, the one of the most important thing we need to find is asymptotes. There are different type of asymptote. If it's possible, we can find the vertical asymptote, horizontal asymptote, and oblique asymptote. The vertical asymptote can be found by simplifying the factors on the top and bottom and making the bottom part zero. So the vertical asymptote of a rational function are found by determining the zeros of q of x, meaning this expression, zeros of this expression. If p of x and q of x are the polynomial with no common factor other than constant, we need to determine only the zeros of the denominator. Okay, that's how you find the vertical asymptote. If, let's say, this is the vertical asymptote for any function, rational function, like let's say x equal to 5 is a vertical asymptote, the meaning of that is the graph of the function, when it approaches to the asymptote, it approaches like this. From the left side, you have two choices, either goes up or goes down. You don't have both of them, just one of them. From the right side, either goes up or goes down. So we need to make a selection which one is the right one, but this is the approach the graph is going to take towards the vertical asymptote. Horizontal asymptote means when x goes to infinity or negative infinity, wherever the function value goes, that gives you the horizontal asymptote. The line y equal to b is a horizontal asymptote for the graph of f if either or both of the following are true. So this is the horizontal line, let's say y equal to b. When the graph of the function approaches to this line, when you go to extreme right or extreme left, from below or from above, one of the case, then that's called the horizontal asymptote. We don't care about the middle part, okay? It's just the extreme right or left. When the numerator and denominator of a rational function have the same degree, we can find the horizontal asymptote by finding the coefficient of the highest degree on the top and then highest degree on the bottom, which is the same degree. So for example, let's say the polynomial function, the rational function is 3x squared plus 5x plus 6, and this is 2x squared plus 7. Then because they have the same degree on the top and bottom, the horizontal asymptote would be y equal the coefficient coming from the top and then coefficient coming from the bottom. That is the horizontal line, horizontal asymptote to this rational function. So always when the numerator and denominator of the rational function have the same degree, we can find the horizontal asymptote. When the degree of the numerator of a rational function is less than the degree of the denominator, then y equal to 0 is the horizontal asymptote. If the degree is more, then there is no horizontal asymptote. So these are the rules you need to follow for finding the horizontal asymptote. Oblique asymptote means you might find the oblique asymptote which is not horizontal or vertical. For example, in this function, the degree on the top is 2 and the degree on the bottom is 1. So okay, here you can find both a vertical and then oblique. You cannot find the horizontal because the degree on the top is 1 greater than degree on the bottom. So in this case, you divide the dividend by the divisor, and whatever quotient you can find here, that y equal that value is the oblique asymptote. That line is the asymptote to the graph. So if the degree on the numerator is 1 greater than degree on the denominator, then horizontal asymptote is not possible, but oblique asymptote is possible. Okay. So these are the some finding. Vertical asymptote you can find wherever the denominator gives 0 for x. The x-axis is the horizontal asymptote when the degree of the numerator is less than the degree of the denominator, meaning y equal to 0. X-axis means y equal to 0. Y equal to 0. For this case, let's say you have a rational function x minus 1 over x minus 2. Then x equal to 2 would be your vertical asymptote. If the degree on the bottom is higher, then y equal to 0 would be always horizontal asymptote. And then horizontal asymptote other than x-axis occurs when the numerator and denominator have the same degree. That only happens if the degree is same. How do you find the oblique asymptote? If the degree on the top is 1 more than degree on the bottom, then you can find the oblique asymptote by dividing and by finding the quotient. Okay. The graph of the rational function never crosses the vertical asymptote. That's not going to happen. But it might cross the horizontal asymptote. Might, but that's not necessary, you know. How do you graph the rational function? Find the real zeros of the denominator for finding the vertical asymptote. Find the horizontal or oblique asymptote if it's possible. Find the zeros of the function, and then which is the x-intercept. Find the y-intercept, and then use all the properties. Find the sign of the function between the zeros to the right and left of the vertical asymptote, and then plot all those things, and then you can plot the graph. I will show you examples. I will go over this one more time while doing the example. So there might be the holes in the graph if the situation like this happens. For example, this is the rational function, and you see there is a common factors x minus 2 and x minus 2. So we cancel this common factor, but at x equal to 2, the function is undefined, and there will be a hole. When we plot the graph, whenever you cancel the common factor from the top and bottom, at that point in the graph you will see a hole. Okay, so okay, let's look at some examples. Determine the domain of the function. Don't worry about the video. I'm making the video for you. Determine the domain of the function. What is the domain? The domain is all real number except 9, because 9 makes the denominator 0, which we cannot have 0 on the denominator. So the domain is all real number except 9. How do you write it? You write all real number except 9. How do you do it? So all real number except 9 is, if you go and check the real number, you want to write down everything except 9. So you want to start from negative infinity, go up to positive 9. You do not want to include the 9, that's why there is a parenthesis. And you start right after 9, so you have to use the parenthesis, comma, infinity. Union between them is the domain. So from negative infinity to positive 9, and then from positive 9 to positive infinity, that's the domain of the function. Determine the horizontal asymptote. For finding the horizontal asymptote, if you check your notes here, where is that? When the numerator and denominator of the rational function have the same degree, here the degree on the top is 3, the degree on the bottom is 3, then the horizontal asymptote would be y equal 3 over 2. So that's a 3 over 2. That's the coefficient of the highest degree on the top, and then coefficient of the highest degree on the bottom. So to find the domain of this type of rational function, first of all, you need to find the factors on the bottom. So in this problem, you have 2 over that thing which is x squared plus 2x minus 35. Find the factors. Find the two numbers, find the factors of negative 35 such that the sum of those two numbers would be positive 2. And that is positive 7 and negative 5. Because if you multiply positive 7 and negative 5, that will be negative 35. But if you add positive 7 and negative 5, that will be positive 2. So from here, as you can see here, the domain would be anything else except positive 5 and negative 7. How do you write it? You start from negative infinity, go up to negative 7, and you put union. You start after negative 7, go up to positive 5. You put union, you start right after 5 and go up to infinity. That's the domain. So on the left side, on the right side, and then one more union here. So this is from negative infinity to negative 7, from negative 7 to positive 5, and from positive 5 to positive infinity. Let me double check. Negative infinity to negative 7 to positive 5, and 5 to positive infinity. Find the vertical asymptote. Vertical asymptote means find the factors on the top and bottom, and cancel the common factor and equate the bottom part to 0. There are no common factor here, and the x square equal to 0 gives you x equal to 0. So the vertical asymptote is x equal 0. There is only one vertical asymptote here, x equals 0. So nonlinear asymptote means it's find the nonlinear asymptote. You have to divide it. This is not the linear means line. Nonlinear means if you divide whatever value you get as a quotient, that's your nonlinear asymptote. Okay. So if I divide this one, x to the power 5 plus 4x cubed plus 8x squared, so that would be x cubed. So x to the power 5 plus 4x cubed, and then cancel this, 8x squared is there, minus 8, negative 8x squared, negative 32, the remainder is negative 32. So this one is your y equal x cubed minus 8 is nonlinear asymptote, which is not the line, it's a nonlinear. X cubed minus 8, I think it's minus 8. Yeah, so that's the nonlinear asymptote. What happened here? Did I do something wrong here? X cubed minus 8. Okay, plus x to the power 5 and then 4x cubed, cancel out. So you have to divide this by x squared, which is 8. That's positive 8, sorry about that, positive 8, not the negative 8. Because it's positive 8, whenever you change the sign, this is positive 32 becomes negative 32. So that would be positive 8 instead of negative 8. Okay, that's the mistake I did. Positive 8. The reason it's a nonlinear asymptote, because after you divide, you can see that this is the top part, dividend over divisor, which is x squared plus 4, can be written as the quotient. Quotient is x cubed plus 8 plus the remainder, which is 32, divided by the divisor. So when x goes to infinity, this part goes to 0, but the leftover part will be this one. Okay, that's the reason this is the asymptote, non-linear. It's not a straight line. List all the asymptote. So how do you list all the asymptote? Let's say I'm also going to plot the graph of this function, though they are not asking graph here, I guess. Oh, then the graph. Okay, there is a graph as well. So first of all, find the factors on the top. This is already factored. On the bottom, there are two factors, x minus 4 and x plus 4. These are the two factors. So the vertical asymptotes, which makes this expression 0. So x equal to 4 and x equal to negative 4. These are the two vertical asymptotes. Horizontal asymptote, because the degree on the top is less than degree on the bottom, y equal to 0 is the horizontal asymptote. Okay, so x equal to 4, x equal to negative 4 and y equal to 0. These are the asymptotes. Now, if we try to plot the graph, let's try to plot the graph here. So here is the coordinate system, and we know x equal to 4 and negative 4 are two horizontal asymptotes. So positive 4 is here, negative 4 is here, and then y equal to 0, which is, let's say I'm going to use this color. This is y equal to 0. Okay, this is the horizontal asymptote. So now you have to plot the graph here, 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 and here. Let's start from the extreme right. The graph of this rational function approach to the vertical asymptote either like this or like this, and then horizontal asymptote either like this or like this. So you just have to find out if it's a positive or negative, and you can do that by choosing some points from here. Let's say x equal to 4, choose something from right side of the 4. Let's say 5. 5 is square is positive, this is positive, so this has to be the right graph. Okay, here from here, either that would be, the graph would be like this or like this. You have to choose either it would be positive or negative. You can do the same thing. If you choose negative 5, then if you plug the value, it will show you the answer is negative, because negative 10. That's the reason this is the part of the graph. And now for each of these parts, here and here, you will do the same thing. When x equal to 0, the value of y is negative. X equal to 0, the value of y is also 0. That is one of the zeros. So now, what happens is the graph of the function would approach like this or like this. You need to determine either it's a positive or negative. So what you can do, choose something from here, let's say negative 3. And that will give you negative on the top and negative on the bottom. So that will be the positive. And if you choose something from here, which is positive on the top and negative on the bottom, that would be negative. So graph would approach to the vertical asymptote like this. So if eventually this would be the part of the graph. So down to the left, where is that? Here, going from up, down, and then up. That's the only graph I can see which is similar to this graph. Okay, that's all for this section.